Hello everyone. In today's video, I am going to cover a topic which is very difficult for some students, or most of the students find it very confusing. The topic is mole concepts. So let's understand first what is the meaning of mole, and then we are going to apply this concept to solve numerical, which are very important for your ICSE board examination. So first understand the meaning now. Let's begin. Mole is nothing, it's a collection of particles like we have been studying in mathematics dozen. Now, dozen is something which is a collection of 12. It can be 12 pieces, 12 banana, 12 books, 12 pieces of pencils, anything. Similarly, mole is also a collection of particles. And what is the collection of particles there in that? So, one mole is a collection of particles that will be equal to a number, and that number is 6.023 10 raised to the power 23. This number is known as Avogadro number. Now, one mole, if we'll say one mole of any atom, so then we'll say that number 6.023 into 10 raised to the power 23 hydrogen atoms, like I have written here. You can say if I am talking about one mole of hydrogen gas, so that means that many number of hydrogen molecules are there. If I am talking about any ion, like here it is 1 mole of hydrogen ion. So that means the hydrogen ion contains 6.023 into 10 raised to the power 23 hydrogen ion. It is as simple as like dozen. 1 dozen of banana will have 12 bananas, not mangoes. So whatever entity is there, if it's an atom, that many atoms are there. If it's a gas, if it's a compound, that many molecules are there. If it's an ion, that many ions are there. So mole concept, if in terms of definition, which is also very important for chemistry exam, because it comes for 1 mark definition. To score centum in chemistry, you need to focus on the definitions in chemistry syllabus. So mole hai, what is that? You can see here, a mole is the amount of substance which contains the same amount of units as the number of atoms in 12 gram of carbon atom. And that amount of substance which is present in 12 gram of carbon 12 is 1 mole. So how much amount of substance is present? We can represent that amount of substance in terms of molecules, in terms of mass, in terms of volume of the gas, if it's a gas. So let's find out what is the relationship between the moles of a substance, volume of a substance, mass, and number of particles. So as I said, the mole means it's a collection, and it is derived, the term is derived from an English word heap, means a collection. And I already told you the collection, the number is known as Avogadro number. So if I will say 1 mole of any substance will occupy how many number of particles, that is my number, which I will denote it Na, means Avogadro number. But this also 1 mole we can relate with the volume of any, if the gas, we are talking about a gas, 1 mole of gas, how much volume it will occupy, what is the mass of 1 mole of a substance. So we can relate it. So we can say, suppose 1 mole of carbon dioxide gas. So how much volume it will occupy? That is 22.4 liter. This is also known as molar volume. That also you need to memorize the definition for your examination. The volume occupied by the 1 mole of a substance is molar volume, and it is a standard value. Similarly, 1 mole of any substance, what will be the mass of that substance in 1 mole of that substance? So 1 mole of, let's take suppose oxygen gas. So what will be the mass? Now oxygen gas is a molecule. So if oxygen mass is 16, so we can say 2 into 16. So there will be 32 gram of gas. So I can say the 1 mole of oxygen gas is equal to 32 gram of oxygen gas. Similarly, we can relate the moles to the mass, volume, and number of particles. Now look at this example. 1 mole of carbon dioxide is always equal to 44 gram, which is the molar mass. So this is the first relationship with the mole and mass. Second, I can relate this to the volume. How much volume will be occupied with by the 1 mole of carbon dioxide gas, that is the standard value, which is 22.4. Now this volume is irrespective of any gas. This molar volume value is same. So if I will say 1 mole of oxygen, 1 mole of hydrogen, 1 mole of carbon dioxide, or 1 mole of ammonia gas, how much volume they are occupying? That is the standard, which is the volume, molar volume 22.4 liter. Or if they will ask 1 mole of these, all these gases occupy how many molecules, we can say Avogadro number, which is 6.023 into 10 raised to the power 23. The difference will be coming in the masses. If I will say 1 mole of oxygen gas occupy what mass? 1 mole of hydrogen gas occupy what mass? So 1 mole of oxygen, how do we calculate? There are 2 oxygen. Each oxygen mass is 16. So I can say 32 gram of oxygen gas is present in 1 mole. Similarly, for hydrogen, it is 2 into 1, 2 gram. For carbon dioxide, 12 into 1 plus 2 into 16, we will get 44 grams. And ammonia, same way, if you will calculate, 17 into plus 1 into 3. Sorry, it's not 17, it's 14. 14 into 1 plus 1 into 3, you will get 17 gram. So this is how the mole is related to the mass, to the volume, to the number of particles. Now let's find out, if we apply the formula, how can we calculate by using the formula. So I can say the mole of any substance in terms of mass, we can say what is the given mass upon, if it's an atom, atomic mass, if it's a compound or molecule, molar mass. Similarly, volume, what is the volume? It's given and divided by its standard volume, which is molar volume. Or in terms of particles, the number of particles divided by the standard number of molecules, which is Avogadro number. Or if you want to remember, you can remember this triangle. So where N is the moles, so W by RAM in terms of mass, this triangle. So if I have to calculate N, this by this will be divided. So I can find out. Same way I can draw the triangle for the volume also. So N will be equal to the given volume and the molar volume. So N can be equal to the volume upon molar volume. So we can find out same way. So now these are the formula. Now let's practice a question on this so that it will give you more clarity. How do we apply this formula and understanding of mole to calculate the mole, mass or number, whatever is given in the numericals. So let's solve this. The first basic thing where the question says, calculate the number of moles in 88 gram of carbon dioxide. So if I will say this, so first thing you have to see what relationship is being taken here. So we are relating here moles to the mass. Now as we know from the formula, the moles of any substance will be equal to its given mass by its RMM. Now they are asking here the number of moles. So I'll check the questionnaire. Okay, what is the given mass of carbon dioxide is given? It's 88. Now what is the RMM of carbon dioxide? You need to calculate. So which is 12 into 1 plus 16 into 2. So it will become 88 by 44, which will give you the answer 2 moles. So my answer is 2 moles. That means 88 gram of carbon dioxide has 2 moles of carbon dioxide. So this is moles and mass ratio. Second question, B part, they are asking same thing in terms of volume. Calculate number of moles in 44.8 liter of carbon dioxide. So again I will see, okay, my ratio given is moles to the volume. And my formula says the moles will be equal to the volume upon the molar volume, which will be equal to the volume is given 44.8. My standard volume is 22.4. So I get 2 moles. So this is how we'll do it. Third again, now it is relating. Now you must have understood by the time that I have to relate the moles to the number of particles, which is given already here. So n is equal to n is equal to given particle is number of particles. Given particle is 12.044, 10 raised to the power 23 divided by 6.023, 10 raised to the power 23, and you will get 2 moles. So did you see here that all the relationships, if you know, you can convert any mass, volume or number of particles into the mole. Okay, let's solve a previous year question that came in 2025. Now let's look at the question. The reaction is given between magnesium and sulfuric acid, and the product forms are magnesium sulfate, water and sulfur dioxide. And the mass of magnesium is given, and then there are two parts given which says the first part, the mass of sulfuric acid you have to calculate, which is required for the reaction, and second part is the volume of sulfur dioxide gas, which is liberated at STP, standard temperature and pressure conditions. So in your ICSE grade 10 you will always get an STP condition, so don't worry about that STP part there. Now how we are going to solve the question, you always have to refer to a balanced equation and what they are expecting in the question. So here if I will see, they have given the mass of magnesium and they are expecting the mass of sulfuric acid which will react with the magnesium. So now if I will look at the equation, so magnesium is reacting with sulfuric acid. So the ratio of reaction of magnesium to the sulfuric acid is 1 mole is to 2. That means 1 mole of magnesium reacts with 2 moles of sulfuric acid. Now if I will see here, they have given the 60 grams of magnesium and they are expecting to calculate the mass of sulfuric acid. Now as the question, we need to get the answer in the grams. So I have to convert this mole ratio to the grams. So if I will see 1 mole of magnesium, the mass is given 24 gram of magnesium is reacting with 2 moles of sulfuric acid. Now 2 moles you can convert into the mass by calculating molar mass of sulfuric acid and multiplying by 2. RMM of sulfuric acid is 98. So it will be 2 into 98 gram. So what I will do, if 24 grams of magnesium is reacting with 2 into 98 gram of sulfuric acid, so what will be reacting with 1 gram of magnesium? That will become 2 into 98 divided by 24 gram of sulfuric acid. But in the question they are asking 60 grams. So my next step is 60 gram will require how much? So 2 into 98 by 24 into 60. So that I will get, you can cancel that, you can get 490 gram of sulfuric acid. This is my answer. So what I did here, I used the balanced equation mole ratio to convert it into gram to get my answer. Now let's look at the second part. Second part, I have to calculate the volume of sulfur dioxide gas. Now again I will refer to my equation, which is the balanced equation, and the data they have given for magnesium. So I will see what is the ratio of magnesium to the sulfur dioxide in terms of moles. So if I will look at the equation, 1 mole of magnesium is producing 1 mole of sulfur dioxide gas. Now sulfur dioxide gas, I have to calculate the volume, that should be in liters, and the data given for magnesium is the mass. So I need to convert the mole of magnesium to mass and mole of sulfur dioxide to the liters. So let's convert that and we can write it. 24 gram of magnesium produces 1 mole of sulfur dioxide. That means 22.4 liter of sulfur dioxide. We can calculate for 1 gram of magnesium produces 22.4 liter divided by 24 gram of sulfur dioxide, and in 60 gram, which is my answer, that finally we can multiply with 1 gram of value, which will give you answer of 56 liter of sulfur dioxide. So I hope it is clear to you. Every question for stoichiometry, you have to refer to the balanced equation and their mole ratio. So this is very important. Once you know the mole ratio, you know how to compare. We can compare the moles and we can convert to any entities they are asking, whether it is mass, whether it is volume, whether it is number of particles. So first you need to do compare in moles and then convert into the unit given and what is expected in the equation. I hope you have understood this basic concept and application to the stoichiometry. Hello everyone. So in today's video I am going to take up all the past paper question and a specific paper question based on mole concepts. Like I explained in my last video about the mole concept and how are we going to apply this to solve the stoichiometry problem. So let's start with the 2026 specimen paper. Now look at this question. The volume occupied by 2 moles of hydrogen gas at STP. As I told you in the last video, every question they will be asking about STP, so you don't have to take tension for STP, or if anything is given without STP, it's not there. So your question will be always mentioning at a standard temperature and pressure condition. Now we have to solve this question based on the data given here. Now they have given the moles of a gas which is 2 moles and they're asking how much volume is occupied by this gas. So as we know the ratio, the 1 mole of any gas occupies the 22.4 liter. So in that ratio, the volume occupied by 2 mole will be 2 times of 22.4. So the answer will be 44.8 liter. So this is my answer C. Let's move to the next question. The ratio between the volumes occupied by 22 gram of carbon dioxide and 10 grams of hydrogen gas. Now here they are asking the ratio of these two gases and they have given the mass. So if I will say the ratios between two gases which is given, it's 22 gram and 10 gram. Comparing ratios, we have to convert into a mole to both of these. So if I will convert this into the mole, I have to divide by the molar mass of carbon dioxide, molar mass of hydrogen which is 2, and you will cancel out, you will get the 0.5 is to 5 mole ratio. So if we'll see the mole ratio, 0.5 to 5, it is 10 times. So my mole ratio, what I am getting, it is 1:10. Again, the correct option is option C. Let's move to the next question. What is the mass of the carbon dioxide which has the same number of molecules in oxygen gas? Now here the comparing gases are the carbon dioxide and oxygen. What data they have given? They have given the mass of oxygen gas and they are asking the mass of carbon dioxide gas which will have the same number of molecules. So if the molecules are same, that means they are having the same moles. So what we can do, we can calculate the moles of oxygen gas first. Now how will you calculate the moles of oxygen? As we have this formula, the moles will be equal to the given mass by the RMM of oxygen gas, which is 3.2 divided by 32. So you will get 1 by 10, which is 0.1 mole. So oxygen present is here 0.1 mole. So that means if the carbon dioxide has to occupy the same molecule, the moles of carbon dioxide must be 0.1 mole. So we got the moles here, but the question they are asking the mass of the carbon dioxide. So what we can do now? We can convert this moles of carbon dioxide to the mass. Now how do we convert? Again we are going to apply the formula, which is moles is equal to the given mass upon the RMM of carbon dioxide. Now we have to calculate the given mass, which is W. The moles we calculated is 0.1. RMM of carbon dioxide, if you calculate, you will get 44. So the answer you will get is 4.4 gram. So every question you have to see what the quantity they have given, whether it is mole, mass or volume or number, what you can compare with them, each and every quantity based on their moles. So we can convert into the moles and we can compare, and then we can get answer what the unit they are asking. So what I have done here, I have converted the oxygen, the mass, converted into the moles, and then as they have given, is it equal to the carbon dioxide. So once I know carbon dioxide moles, I have converted this into the grams of the carbon dioxide. Okay, let's move to the next question. Now this question is a 3-marker question, which is very common in ICSE board examination, so you have to understand it very well. Now here the reaction is given where ammonium dichromate is heated and it produces the 3 compounds which is already given in your question, and it will be balanced equation. You don't need to worry about the balancing part. Now let's look at the question, what the values they have given, what quantities, and what you have to calculate. So they have given the mass of ammonium dichromate, and then they are asking the number of moles of ammonium dichromate that undergoes. Now this is a very direct question. They are asking for same compound. So ammonium dichromate, the mass is given 126 gram, and for same compound they are asking the moles. So now we know the formula again. We will divide this by the molar mass of ammonium dichromate, and ammonium dichromate molar mass is, when you calculate, you can calculate easily as the atomic weights are given. It will come 252 grams, and you will get 0.5 moles. So my first answer is 0.5 moles of ammonium dichromate is there. Second question, they are asking the chromic oxide. Now chromic oxide is my product. Now if they have given for the ammonium dichromate and they are asking for chromic oxide, you have to see the balanced equation mole ratio. So if I will look at the balanced equation mole ratio, 1 mole of ammonium dichromate produces 1 mole of chromic oxide. So if I will write here ammonium dichromate ratio to the chromic oxide in my balanced equation, it is 1 mole to 1 mole. But based on the grams given of ammonium dichromate, it's 126. So what I got in the previous answer, that is 0.5 moles. So in my question, the number of moles present is 0.5 mole. 1 mole, what is there? That is the standard ratio when the equation is balanced. So 0.45 moles will also, what will it produce? So we can say 1 mole produces 1 mole of this. So 0.5 mole will also produce 0.5 mole of chromic oxide. Now the question is they are asking in the mass. So I can convert this 0.5 moles of chromic oxide to mass of the chromic oxide. We can apply the simple formula. The moles is equal to given weight by RMM of chromic oxide. We can calculate the RMM and we can find out the value. So W will be equal to 0.5, and when we'll calculate the chromic oxide mass, it is 152 gram, and then we can calculate. You can calculate it easily in the exam. The calculations are not very hard. You will get the 76 gram of chromic oxide is formed. So this is B part is done. Now let's look at the third part, volume of nitrogen gas evolved. Now again we have to go back to my balanced equation. Now in the balanced equation, the relationship with ammonium dichromate to the nitrogen gas, it is again 1:1 mole. So again I'll write down here ammonium dichromate to nitrogen gas, the ratio is 1 mole to 1 mole. In equation, what the values we have calculated, we got 0.5 mole. So that will also produce same mole, because the ratio is 1 mole to 1 mole, and so same moles of reactant is producing same moles, so and nitrogen gas. So ammonium dichromate will also be producing the same moles of nitrogen gas. But here you have to calculate the volume of the gas. So we got to know the moles of the gas. So then we can apply the formula volume by the molar volume, which is volume we have to calculate, which is 0.5 multiplied by the standard volume is 22.4 liter, and you can multiply easily and can get the answer, which is 11.2 liter. So you can see these all questions, every part of this question is related to each other, and it starts with the moles of ammonium dichromate because this is a thermal decomposition of ammonium dichromate, and the question they are asking related to the products form, the volume of the products and mass of the product. So whatever given in the moles in the first part which we have calculated, we will take that ratio and find out all the answers with respect to that 0.5 moles. Now let's move to another specimen paper question. This is an MCQ question. Now for MCQs always sometimes they are tricky and they are not involve so much of calculation, so you have to be very smart in solving. Now let's look at this question now. The atomic mass of sulfur, oxygen and helium is given. Now you have to calculate which of the following statement regarding the number of atoms in 32 gram, 16 gram is correct. So I have three elements, sulfur, oxygen and helium. The mass is 32, 16 and 4. Now sulfur mass is 32, that means it represents 1 mole. Oxygen represents 1 mole and this represents 1 mole. That means all are 1 mole is given. Now let's see and compare in the moles. 16 P statement says 16 gram of oxygen contain 4 times the number of 4 gram of helium. Now 16 grams of oxygen means they are comparing oxygen to the helium. Now 16 gram of oxygen means they are talking about 1 mole contains 4 times the number of atoms as in 4 gram of helium. Now 4 gram of helium, if you see, it is the same 1 mole. So and we know that 1 mole of any substance contain the same number of particles. So this statement is wrong. Now let's look at the second statement. 16 gram of oxygen contain half the number of atoms as 32 gram of sulfur. 16 gram of oxygen, again it's a 1 mole, and 32 gram is again it's a 1 mole. So doesn't matter which substance is that, 1 mole of any substance will contain the same number of atoms. So this statement is also wrong. So my option is D here for the correct answer. Now let's solve the 2018 question. Again, this is a reaction based question. You can see a reaction is given where aluminum chloride reacts with water from aluminum hydroxide and methane is evolved. So the first question they are asking that what mass of aluminum hydroxide is formed from 12 gram of aluminum carbide. Now for every question, as I am telling you again and again, you have to see what you have to find out and what is given. Now here they have given the mass of aluminum carbide. So I will write down this aluminum carbide, and they are asking the mass of aluminum hydroxide. So what is the mole ratio present in the balanced equation? So I can see here 1 mole of aluminum carbide produces 4 moles of aluminum hydroxide. This is what I am taking the data from the balanced equation. But in the question they have given the 12 gram of aluminum carbide will produce how many grams of aluminum hydroxide. So I need to convert this mole into mass. So 1 mole of aluminum chloride, you can see they have given directly the mass, so you don't need to calculate the molar mass here. So it will form, I can say 144 gram of aluminum chloride produces. Now 4 moles also we can calculate the mass, as they have given mass for 1 mole of aluminum hydroxide is 78. So 4 into 78 gram of aluminum hydroxide. Now what I can do, if I know from the balanced equation 144 gram produces 4 into 78 gram. So 1 gram will produce how much? 4 into 78 upon 144 gram. And in the question it is mentioned to calculate for 12 grams. So 4 into 78 upon 144 into 12. Now you will solve this equation and you will get the answer. When you calculate this, 12, 3, and you will get 26 grams of aluminium hydroxide are formed. So I hope you are clear this. What I am doing it here, again the same thing. The mole I am converting into the mass, because the question I have to calculate answer is the mass, and then I am comparing the mole ratio to the mass ratio in the balanced equation. Second part, you see the volume of methane at STP from 12 gram of aluminium carbide. Now if I will see the balance equation here, we can see here the aluminium carbide ratio to the methane is 1 mole to 3 moles. So 1 mole of aluminium carbide produces 3 moles of methane. So 12 gram will produce how many liters of methane gas? So again what we have to do here, so if it is they are giving the grams, I have to convert this into mass. So 144 gram of aluminium carbide, it's producing 3 moles. 3 moles means, if I will say in the liters, 3 times 22.4, because 1 mole occupies 22.4 liters. So I can say that 144 gram of aluminium carbide produces 3 into 22.4 liter of methane. So 1 gram will produce how much? 3 into 22.4 upon 144, and 12 gram will produce 3 into 22.4 upon 144 into 12. So again, so you will get here, you can divide this 22.4 divided by 4, whatever answer you are getting it, this is 5.6 liter. So it will occupy 5.6 liter this gas. So I hope, is it clear to you that the method which I am doing it, I am just comparing the ratios whatever it is given in the question and moles converting to that quantity. Hello students, welcome to my channel. So today I am going to cover the remaining topics of mole concept topic, which is vapor density, empirical molecular formula, Gay-Lussac's law and Avogadro law. Let's do one by one. So let's begin. Let's start with the vapor density. Now first, for the board exam point of view, you need to prepare in two ways. First is the definition of that concept, and then other is the formula and they are numerical based on that. Now this vapor density is a very small concept, so you will get directly question based on the formula. So let's look at and understand the definition for vapor density. It is defined as the ratio between the masses of equal volume of gas or the vapor of gas and hydrogen under the same condition of temperature and pressure, which means if I have any gas as compared with hydrogen which has the same volume, so if I will say 1 liter of hydrogen I have and 1 liter of nitrogen I have, and the conditions are same with respect to temperature and pressure, and if I will calculate the ratio of their weight of nitrogen with respect to weight of hydrogen, that term will be known as vapor density. So it's a ratio basically, so it has no unit. Remember that while calculating, when you write down the answer, it will have no unit. Now let's look at another formula, which is the calculation of molecular mass with respect to vapor density. So if the vapor density we know for any gas, if we multiply by 2, or we can say double the vapor density, will give the molecular mass. So that is the two ways to calculate the two formulas. Now let's practice the question on that. These are all the past paper question which I am solving with you, and the remaining more sheet I will cover I will upload in my drive, and I will share the drive link with you so that you can access to all the resource material there. Now let's look at this question now. If the empirical formula of two compounds is CH and vapor density is 13 and 39, find out their molecular formula. So there are two compounds. Let's assume the two compounds are X and Y, and both molecular formula is CH. So both empirical formula is CH. So CH means the empirical formula mass is 13 for both. Now what they have given is the vapor density. Vapor density, let's assume that 13 is for the X and 39 for Y. So with vapor density, we can calculate the molecular mass of this both gases. So which will be 2 times of 13 will be 26, and 2 times of 39 will be, you can calculate, you can pause the video and you can solve it, 78. So now we have to see the ratio of the empirical formula to the molecular mass. So if we look at the first gas which we have assumed as X. So what is the ratio of empirical formula to molecular mass? It is times 2. That means if I will have a molecular empirical formula of CH, I will multiply it by 2. I will get the molecular formula. Similarly for Y, it is 78 by 13. I will get the 6. That means if I will take the molecular formula multiplied by 6, I will get the molecular formula. So empirical formula multiplied by the number of times the molecular weight is, that will give you the actual formula. So this is a just direct application of the concept, the question in the vapor density. Now let's look at the next question. Next question, where the gas volume are given. So there is a gas X and there is a hydrogen gas. The density of both gases are given. Gas X is 0.09, gas this is, calculate the vapor density. So as we know in the formula, you are going to write down the formula. The way of answering also matters in the exam. So you are going to write down the whole formula first. So vapor density will be the weight of gas X divided by the weight of hydrogen gas. So we will get weight of gas X. I think I have written ulta here, something wrong. This is 1.35, this is 0.09. So here I can say 1.35 divided by 0.09, and if you will divide it, you will get 15. Okay, so what will be my answer for vapor density? 15. By applying directly to the formula, I got the 15. Now second part is the molecular weight. Now molecular weight is 2 times of vapor density. So again you are going to write down the formula. Vapor density of gas X, which will be equal to 2 times 15, which is 30. So my answer is 30. This is also a very easy question. It's a 2-marker question as there are 2 parts and you will be able to solve it very easily. So this concept is done. Let's move to the next concept. This is also a very small concept, Avogadro law. Again, you have to prepare 2 ways. One is the definition and other is the numerical based on that. Numericals will be directly based on that. So you have to just practice the numericals and memorize the definition. Now look at the definition and understand it. This law says that equal volume of all gases under similar condition of temperature and pressure contain same number of molecules. So it means if the conditions are same for 2 or more gases, let's take we have gas A and gas B. If they have the C present at same conditions and the volume is same, let's take 1 liter of A and 1 liter of B are present in the same condition. So both of these gases will have the same number of molecules. So this is the very important point here. So if I will take 1 liter of nitrogen, 1 liter of hydrogen, 1 liter of ammonia, 1 liter of oxygen, all these will contain the same number of molecules. So this concept we are going to use the calculate the number of molecules or the volume anyway. Now let's look at this question. If 150 cc of a gas A contain X molecule, so how many molecule of gas B will be present in 75 cc? So gas A, they have given the volume is 150 cc and it is having the X molecules. And they are asking for gas B, which volume is 75 cc. What is the volume? So we have to see what is the ratio of volume of gas A to B is there. So if 150 cc of gas A has X molecule, that means if gas B is having 150 cc, this will also have X molecules. But in the question they are asking for 75 cc. So what we can do, we can relate gas A volume 150 cc to gas B 150 cc, and then we can find out for 75 cc. So 75 to 150 is the half of that. So we can say here like 150 cc of gas B contains X molecule. So 75 cc of gas will contain what? X by 150 into 75. So X by 2 molecules or 1 by 2 of X. Any way you can write. Both will be accepted in the board paper to get the marks. So this is again the same thing what we are just comparing the volume ratio, and that same ratio will be for the molecule. So if 150 cc to 75 is half, the molecule will also become the half of that. So these type of question you can practice it, and these are just directly formula you can apply and you can get the answer. Also memorize the statements well, because you get 1 or 2 marker question in your section B for the writing the definitions, or in your section A you get 1 question of 5 marks where they give the definition and you have to identify the name of the following or name of the law or any way. So for that you should be able to know or you should be able to understand these laws well. Okay, let's move to the next topic now. Next topic is empirical formula and molecular formula. Again, the first thing you need to memorize is the definition, and you should, when you memorize the definition, you should understand it well and remember the keywords. In case you are not able to recall during the exam, you should be able to frame your definition using the correct key scientific vocabulary. So if I will look at the empirical formula, it is the simplest formula which gives the simple whole number ratio of atoms present in one molecule, and molecular formula is the actual number of atoms. So let's suppose take an example. If I have a compound, let's take ethane, and the question says identify its molecular formula or empirical formula. So molecular formula, as we know, this is C2H6. Is there any further simplified ratio I can write for this between C2H? So you should see there are 2 elements present, C and H. What is the simple ratio between that? It is 1:3. So the empirical formula is this, which gives a simple ratio. How to get the molecular formula from empirical formula? Which number I should multiply to get the actual number of atom? So in case of ethane, 2 times. So if I will multiply by 2, I'll get C2H6, which is my molecular formula. So you can understand that molecular formula is the actual formula which gives the actual number of atoms present in a molecule of a compound. Empirical is the simple ratio. Or you can understand in another way if you are finding it difficult to understand from the definition. I'll give you an example. Suppose in your class there are let's take 10 girls and 20 boys. Let's take an example. So if somebody asks you a question, what is the ratio of girls to boys in your class? So we can say 1:2. But if somebody asks you what is the number of girls and boys, then we'll not say 1 and 2. Then we'll say it is 10 girls and 20 boys. So that number of girls is the actual number, but what is the ratio between them is the empirical formula. So I hope you must have understood by now the difference between empirical formula and molecular formula. Now let's look at the pattern of the question which you get in the board exams. Now the first basic type of question is that which comes usually in the MCQs of section A. They'll give the empirical formula and they'll ask you to what is the molecular formula, empirical formula is that. So they will give you a molecular formula, like here the first one you see C6H6. So if we divide this by 6, a common number, I'll get the empirical formula CH. Second, again a common number which is 3, so I'll get 2 6O. So which is the simplest whole number ratio, C2H2 CH. Now let's look at this example. This is a acetic acid. Now here sometimes student they get confused by looking at that example. So what you have to do, there are 3 different atoms are there, right? You count and write it. C is 2, H is 4, oxygen is 2. What is the simple ratio there? You can write down the answer. Sorry, C is 1, C1, H2O1. There is no need to write down 1. So what we can write down? We can write down as final answer is CH2O. So if the formula has the repeated atoms, you can count all together, and then you can find out the simple formula. So I hope it is clear to you the basic difference between empirical and molecular formula, and you will be able to find it out. If the molecular formula is given, you should be able to find out the empirical formula. One more thing, it's not always that every substance or every compound has empirical and molecular formula different. If I will ask you, suppose methane, what is the empirical formula? What is the molecular formula? So it is the same thing. So there is no further I can do the simplification. So molecular formula and empirical formula, here it's not distinguishing here. So it's the same thing. If I will say empirical formula is the molecular formula here. So it has no empirical formula here. So this is because it is the molecular formula is the simplest ratio here. So we are not able to simplify it further. So remember that. Not all. Usually in exam when they will give you the example which can be simplified further. So ICSE board doesn't go into the problems where you have some complexities there, as it is not prescribed in the syllabus. So you will follow the simple molecules and find out the simple formula based on that. Usually in MCQs, if they give, suppose there is an MCQ present and they will ask you whatever the molecular formula is given, what is the empirical formula, which is the simplest ratio you are getting it, that one. So other options will be given it, like where there is simple ratio is not possible. So that way we can calculate it. So I hope this till here it's clear to you. Now let's move to another concept. Now let's try to understand and solve the questions based on empirical formula and molecular formula. So as I already discussed with you the meaning of empirical formula and molecular formula, but how do we apply that concept to find out the empirical and molecular formula based on the percentage composition if given? So we can do different type of question which are possible for ISC board examinations. So first type is the question where you need to calculate only empirical formula, and they will give the percentages of the elements present in that compound. So if you look at this question, an organic compound on analysis, it gives hydrogen and oxygen. Determine its empirical formula if it contains 12 atom grams of carbon. So to calculate empirical formula, you can draw a tabular column, and calculate based on the column, and it will be easy, and presentation also will be very neater, and it will be very easily understand by the examiner who is checking your answer sheets. So let's look at these, what are the elements present. So if I will make a table here, so my first column will be which elements are present in this compound. So if I will look this question, I can see there is an hydrogen, oxygen and carbon is present in this compound. So I will write down each element present. So oxygen, hydrogen and carbon. Now let's look at the question. What is the percentage composition given here for each element? So if you see the percentage for oxygen, here it's given 51.42. For hydrogen it is given 6.48. Now in this the carbon percentage is not given. So what you have to do? You have to subtract from 100 the remaining 2 percentages. So usually they give, sometimes they don't give. So you can do it by adding and subtracting from 100. This you will get subtracted, you will get 4.2. Okay. Sometimes what happened, the question is there when they give only carbon and oxygen, they don't give. So that means its remaining is hydro. If they say the question there is a hydrocarbon is there, on any organic compound because they contain hydrogen. So first thing you should check what the percentages are giving. Are they making up to 100? If not, that means the third element is having the remaining percentage. So I have written these two columns which are from the data. Then you see the atomic weight are given. You will write down the atomic weight of each element present here. Oxygen is 16, 1 and 12. Now your calculation starts from the fourth column. Now fourth column, what you have to do? We have to find out the relative number of atoms. Now what is relative number of atoms? In a compound, like if I will say oxygen, hydrogen and carbon are present, what is the relative number present of each atom with respect to each other? So what we will do? We will take the percentages given, divide by its atomic weight. So hydrogen, like it is 6.48, divide by 1. Similarly carbon 42.1, divide by 12. This you have to get the answer up to 2 decimal places. So you will get here 3.21. You can divide it 6.48 and here you will get 3.40. You can pause the video where the calculation part is there and you can divide it and then you can continue further to the next step. Then next, once we get the mole ratio of all the atoms, we have to guess the simplest ratio. Now simplest ratio means which mole is the least one here. So if I see here oxygen is 3.21, which is the least number of mole, I will divide that by all relative number of atoms. So I will divide oxygen by 3.21. I will divide the hydrogen number of atoms by 3.21 and I will divide carbon also 3.50 by 3.21. So if you will divide again, you just do it till 2 decimal place, you will get this 1. If you will divide this, you will get 2.01 and this will be 1.09. Now this is 1. Now 2.01 can be taken as 2. Similarly 1.09 can be taken as 1. So I got the simplest and made mole ratio here. So in my compound, my simplest whole number ratio of atoms is, so it's oxygen, hydrogen to carbon. It is 1:2:1. So I can write down the formula as, my empirical formula is 1:2:1. Okay, so I got this 1:2:1. Now in this question they have added one more part here if you read it carefully. Determine the empirical formula if the carbon is 12 atom, means in that compound carbon is 12 atoms. So now we will apply this to my ratio here. So carbon is 12. So that means I'll multiply by this to 12. So I have to multiply by all number to 12. So what I will get? Multiplied by 12. So I will get C12H24O12. So this is what you will get the empirical formula as an answer. Now this question is completed here as they are not asking the molecular formula. So it's a 2-mark question. 1 mark will be given for all the correct values you have placed in the tabular column and 1 mark will be given on calculation of the empirical formula and writing the answer. So this is done. Now let's move to the next type of question. Now this question is there where you have to calculate the molecular formula. You have to find out. Now molecular formula you can find only when you know the empirical formula. So what usually is the relationship between molecular formula and empirical formula is, molecular formula is equal to the empirical formula times n. How many times you are multiplying by which factor to get the molecular formula. So in this question we need to calculate the empirical formula and then we will have to calculate the empirical formula mass, divide by molecular mass and then we'll get the n and we can calculate. So let's do stepwise. So step 1 is calculation of empirical formula. So empirical formula calculation requires that tabular column calculation. So we will do it again the similar way which I did it in the previous question. So I will make a column here, which is the element present here, percentage composition, then what is the atomic weight given here, then you will get the relative number of atoms, and the last column will be the simplest ratio, and you will close your table. I'm drawing freehand. You can use the ruler in your answer sheet so it will look neater. Now what are the elements given here? It's in hydrocarbon, so only carbon and hydrogen is there. So let's write down the values. Now carbon percentage is given. Okay, so this question does not give any percentage of carbon. They have given the mass of the carbon and hydrogen in a compound. So we need to convert this given mass into the percentages. So how do we convert into this one? You see that the mass of total compound is 0.70, correct? And in that 0.60 is the mass of carbon. So remaining hydrogen mass also we don't know. So we can calculate it by subtracting from 0.70 to 0.60. So let's write off a carbon percentage. 0.60 is the mass of carbon divided by the total mass of the compound, which is 0.70 into 100. You calculate this, you will get 85.71 percentage. Now hydrogen mass in the compound is not given here, so that will be 0.70 minus 0.60 divided by the total mass of the compound into 100. So you will get 0.10 divided by 0.70 into 100, and you will get answer 14.28 percentage. Okay, so I hope you understood the hydrogen part, how to calculate the percentages, the remaining if element mass or nothing is given, and if the mass is given, how to we convert into the percentage of elements for the calculation of empirical formula. Now let's look at the mass given in the question. So you don't need to worry about the molecular weight, that will always be given in the question. Now let's do the next step, which is the division of your percentage by its atomic weight. So which is 85.71 divided by 12, which will give 7.14, and this will give hydrogen 14.28 divided by 1 will be 14.28. Next step is the least number of atoms will be divided to all the relative number of atoms. So we will divide this by the least answer, which is 7.14. Here I will get 1, here I will get 2. So my mole ratio I am getting C1 and hydrogen. So what is the ratio of atoms is C is to H is 1 is to 2. So my empirical formula, as you can see here, what we are getting by calculation is CH2. So this is the first answer of this question, because this formula we are going to use to calculate the molecular formula. So before we go to calculate the molecular formula, next step we have to calculate the empirical formula weight, which is basically the weight of CH2. So if we'll do 12 plus 1 into 2 will give the 14. Now molecular weight we have to calculate. They have given already the weight here, so we have to find out the molecular formula. So what is given here, you will write it. Molecular weight which is given here is 70. Now to calculate the molecular formula, we need to find out the n, as I showed you in the formula before. If we know this n, we can find out the molecular formula. So what we will do to calculate the n, the formula is molecular weight divided by empirical formula weight, which is 70 by 14. You divide it. You can pause the video and calculate. So you will get an answer 5. That means the value of n is 5. So now my molecular formula is empirical formula times 5. So I will do that many times of empirical formula. So if my empirical formula I got in CH2 and I'll do the 5 times of that, so I will get C5H10. So my molecular formula for this numerical is C5H10. So we got the answer here. So molecular formula, empirical formula, and this is the method you will calculate. So this is the basic method every time you have to do if question comes to calculate molecular formula. We have to calculate empirical formula, we have to calculate second step, which is the empirical formula weight, and third step we have to calculate the n, and finally we have to calculate the what is the actual formula. So I hope it's clear to you. And then let's move to the next question, a different type of question where you may get some variation in that. So some data are not directly given. Let's move to the next question. Now look at this question. This question, see, the percentages are given and rest is hydrogen. So again, they are asking the empirical and molecular formula, and vapor density is given. So instead of giving molecular weight, they have given the vapor density. So we can calculate the molecular weight, but that is in the next step. So my step 1 is here to calculate the empirical formula. So same thing again, I am going to do that tabular column I am going to make, which is the element, percentage, composition, atomic weight, then relative number of atoms, then simplest ratio. So let's write down what are the elements given here. Carbon and oxygen, and rest is hydrogen. So that we can calculate as we did before also. So carbon percentage is given 57.82, oxygen is 38.58, and this hydrogen, when you calculate 100 minus addition of 57.82 plus 38.58, you will get 3.60. So I'm extending the table because this data is not fitting it here, and then I will close the table. Remember, draw this table very neatly, and all calculation should be seen very clearly. Atomic weight is it already given, so we will write it. And now the next is relative number, which is the division of the percentages by its atomic weight. So 38.58 divided by 1, 3.60 divided by 1. What answer you are getting, please calculate it. You can pause the video and calculate on your own, and you can recheck. Here you will get 81, 2.41 and 3.60. The last step is, which is the least number of atoms you are getting, you are going to divide all other relative number of atoms by that value. So 4.81 divided by 2.41, 2.41 divided by 2.41, 3.60 divided by 2.41. Now here comes the difference in the calculation here from the previous question. So 4.81 divided by 2.41 is exactly 2, a whole number. This is exactly 1, but when you will calculate here, you will get 3 by 2 or 1.5. Now I can't take the any fractional value as a simplest ratio, so I need to convert this value to the nearest whole number. So to the 1.5, what number I can multiply to make it a nearest whole number? So if I will, you have to think that. So I can multiply it by 2, it will become 3. So if I am multiplying the hydrogen number of atoms by 2, I have to multiply the remaining atoms also. So my empirical formula here is what I got first. If I will say the ratio of carbon, hydrogen to the oxygen, what I got before is 2 is to 1 is to 3 by 2. But as the fractional value of number atoms cannot be accepted, we have to convert this into a nearest whole number. So what I am getting it here, C4O2H3 3. So what is my empirical formula now here? Empirical formula is C4O2H3. Now you can write down in any way. You can write down C4H3O2. That does not make any difference. It's up to you which order you can write it. Empirical formula just shows the simple ratio of atoms. So you can write down oxygen first or hydrogen first, doesn't not matter. So my first part is done, step 1. Step 2 is you will calculate the empirical formula weight, because that we are going to use the molecular formula from that. Empirical formula weight, that is addition of all this. So C4H3O2, that will be 12 into 4 plus 1 into 3 plus 2 into 16. You will get here, you add all that, you will get 83. So my step 2 is done, empirical formula weight. Now step 3 is that calculating the molecular weight. Now as you know, the molecular weight, it is 2 times of vapor density, because in this question you see they have given the vapor density. So I am going to calculate the molecular weight using the data given in the question, which is 2 times of vapor density, 2 times of 83, which you will get 166. Now I have both the weights, empirical formula and molecular weight. So what I am going to do, finding it out, the N. Now N is the molecular weight divided by empirical formula weight, which is equal to 166 divided by 83. You will get 2. Remember, whenever you are finding it out, the value of N, it usually will be coming 1 time or 2 time or 3 time or 4 time, not more than that in ICSE, whatever you're getting the question in the board exams. And it will always be in whole number. So if you're not getting somewhere in whole number, that means you are doing some step wrong. So you can go to your table and check your division, because you have to divide and get the answer in 2 decimal places. And especially you have to be very careful when you are getting this division here in the simple ratio. If you are getting 2.01, 2.111 or 2 till here, you will take as it is. But if your answer is there as, let's say, suppose you are getting 1.25, you can't take it close similarly as 1. You have to multiply by any number to get the nearest whole number. So 1.525 is always to be multiplied by 4. So remember, whenever you are getting 1.25 or close to that, you will multiply it by 4. 1.5 you will multiply it by 2. Usually these are the most common values which you get in the simplest ratio when you calculate in the tabular column to get the empirical formula. So if any other than that, maybe you can get 1.75 also, that also you can multiply to get the nearest whole number. So here I got this 2. So that means my empirical formula was C4H3O2. Now to calculate the molecular formula, which is the next step, I know the value of N, which is the empirical formula, times N, which is C4H3O2 times 2. So I can write down C8H6O4. So this is my final answer. Now this question, when they ask you empirical formula, molecular formula both, it usually comes for 3 marks, because this table is there for where you get the empirical formula, carries 1 mark, and then empirical formula weight, molecular weight, and your answer comprises of each of half, and you will get the 3 mark total for this question usually. But sometime if the calculations are easier, they give directly for 2 marks also. So this question always from this topic, it comes for 2 marks or 3 marks for the calculation. I hope you understood the calculation and understood the various types of the question possible. And please practice it more, and I will post in the drive which I am going to share with you the past paper question and the specimen paper question from this concept, so that you can do it for practice for yourself. Okay, let's now go to the last concept of this chapter, which is the Gay-Lussac's law of combining volume. Now this law applies to the gases when they react. and what is the ratio of volume it is reacting. That is what is mentioned in the law. So again, you have to memorize the definition to be able to answer 1 mark question in your board exam when they will ask you define or state Gay-Lussac's law of combining volumes. So now let's understand this law. When the gases react, they do so in the volumes which bear a simple ratio to one another and to the volume of the gaseous products, provided all volumes are measured at same temperature and pressure. So let's look at a very simple equation. If hydrogen gas is reacting with nitrogen gas and forming ammonia, right? So what is the ratio of the reactant gas is here, which is 3 volume to 1 volume of nitrogen. It is producing 2 volume of ammonia. So all this ratio is always constant provided they are measured at same temperature and pressure. So I can always say that when these gases are reacting, the ratio among the reactant and the ratio from reactant to the product, it is always constant. So that will remain always constant. So if you are going to prepare, let's take 300 volume of hydrogen you have taken. So this will become 100 volume and you will get 200 volume of ammonia. So again the ratio will be always 3:1:2. That is the overall understanding of this law. So now let's apply this concept to find out the numericals and solve it. Now look at this past paper question here where they will give the equation is ammonia is burning in oxygen as reaction shown here, where the value of ammonia in terms of volume is given. So I will write down this equation again here. 4 ammonia react with 3 moles of oxygen produces 2 moles of nitrogen, 6. Now this law is compared in terms of volumes. If I will see here, 4 volume of ammonia react with 3 volume produces 2 volume and 6 volume of water. Now what it is given in the question, 240 cc of ammonia is already mentioned which is being used along with 300 cc of oxygen. Find out the composition of resultant gaseous mixture. Now you have to take care this underlining word. Composition of resultant gaseous mixture means whatever gases, all these are gases here because this law applies to the gases only. All these are gases here. So which gas means which, how much product produced, what is the amount of that, and if any reactant is left over, what is the amount of that reactant left over in the CC. So here we have 2 reactants, ammonia and oxygen. That means definitely one will be present in excess quantity and one is going to be used in the reaction. So the first question comes here, how do we find it out which is going to used in the reaction? Because the one which is used up in the reaction will directly form the product. So the formation of product will depend upon the reactant which is getting used up. The reactant which is excess, which is present in extra quantity, the product will not depend upon that. So this question has 2 parts. So first step is we have to find it out which reagent or reactant is used up, okay, and the other one reactant will be left over and how much, because that will also be a one part of an answer. So let's find it out. For that, what you have to do, it's very simple here. Whatever the volume is given, you will divide by the stoichiometric coefficient of that. So if I will divide by 4 and for oxygen it is giving 3, so you will get here 60 and you will get here 100. So we are getting the value of 60 and 100 is the cc for the oxygen. Now whichever answer is less, that will be the reactant which is consumed, and whichever is more, it is present in excess quantity. So my first step, I came to know and I concluded no, ammonia is the one which is going to be used entirely. So there will be no ammonia left in the equation. Whatever will be left in the equation, that is the oxygen. So first question, I will find it out, the first part, the amount of oxygen will be left over. So I will write down amount of oxygen which is left unused. So to that we should know how much it is used. Now we can see here which is the amount which is the ammonia which is used here. This is 240 MCQ. So again what I will do, I'll write down the ratio here. NH3 is to oxygen, and ammonia in the balanced equation it is 4 volume using 3 volume, but in my equation it is given 240 cc. So how much volume of oxygen it is going to react, because I will take ammonia volume as a standard which is going to decide how much reactant to be used and how much product will be formed. So that is my standard value. I am not going to touch the cc of oxygen which is given to calculate the amount of product formed or what is involved in the reaction. So you do cross multiply, you will get it. The x will be equal to 3 multiplied by 60, 180 cc. So how much ammonia, what we are calculating, first we calculated this much it is used now. Now x is the used oxygen which is 180 cc. How much is left which is unused? So oxygen unused will be equal to the how much total given in the question. The amount of oxygen given is 300 cc. So 300 cc minus 180 cc which is consumed, you will get 120 cc. So this is the one component of the mixture which I found it, oxygen is unused. Now we have to find out how much product volume is produced. So there are two products, we are going to find out each one of the products, so how much it is produced. Let's look at this. So amount of nitrogen formed depend upon ammonia. So amount of nitrogen formed, again we will write down the stoichiometric ratio. 4 ammonia is to nitrogen. So if you look at the reaction balanced equation, 4 volume is producing 2 volume. So I will write down there 4 volume is producing 2 volume. So in my question the volume of ammonia is 240. So 240 will be producing how much? Again the same thing, cross multiply. My x will be 240 into 2 upon 4 which is 120 cc. So amount of nitrogen produced is 120 cc. Now the last product is left, amount of H2O formed. The same thing again we are going to do. Ammonia we are going to compare with the water in the balanced equation. So if you see in the balanced equation, 4 volume of ammonia is producing 6 volume of water. So I am going to use that. So 4 volume to the 6 volume. Here 240 cc will be producing x. So x will be equal to 6 into 240 upon 4. That you will solve it. You will get 360 cc. So now I got all the composition of each gases which is produced and used up. So your answer, finally in your answer sheet, you have to write down very neatly at the end again. Volume of, you have the reactant here, oxygen unused. That answer you will write it 120 cc. Volume of nitrogen produced or formed which is equal to 120 cc. Volume of water produced, steam produced 360 cc, and volume of ammonia is 0 cc. You don't need to write because that we are already showing it is the limiting reagent. So this is the way you can find it out. Now you have to be very careful in finding the which reactant is going consumed and which is excess. So very carefully you have to calculate, and you will take the stoichiometric coefficient and you will take the volume and divide the volume by the stoichiometric coefficient. The one which is least value will be the reagent which is going to used up. So I hope this method is clear to you, and this question is of 2 marks it comes, so you can find it out. Now let's solve the another question. Now look at this question again. There is a reaction given where is methane burned in oxygen and forming CO2 and H2. It's a combustion reaction. And they have given some cc of oxygen burned in ethane, some cc is given. And you have to calculate the two parts. It's a 2-mark question then. Volume of CO2 form, volume of unused CO2. The same thing we are going to apply here now. C2H6 plus 7O2 forms 4CO2 plus 6H2O. So what is the ratio here? This is 2 volume react with 7 volume of oxygen, produces 4 volume of CO2, produces 6 volume of water. Now in my question, the volume of ethane is given 300 cc and volume of oxygen is given 1250 cc. So first thing we have to find it out that which is the reagent is going to be completely used up in the reaction and which reagent will be left over. So as mostly the reactions, whatever you're getting in your stoichiometric or Gay-Lussac's law, there are 2 reactant and one will be in excess, one will be used up. So same thing we will follow here. With 300 divide by 2, 1250 divide by 7. So once you will calculate 300 divide by 2, you will get 150 cc and 1250 divide by 7, you will get 178 cc. Now the least volume is for ethane. So ethane is the reagent which is going to used up completely. So now I got to know that this is my reagent which is used up completely. So I am going to take this 300 cc value to find out the moles of volume of the carbon dioxide form and volume of the unused oxygen. So let's do the first here. Now volume of carbon dioxide form will depend upon the C2H6. So C2H6 is to the volume of carbon dioxide. In my balanced equation, the 2 volume is producing the 4 volume, or you can say technically it is getting double. 2 volume produces 4. So I have 300 volume cc. How much it will produce? You can do it x. So x will be 4 into 300 by 2. It is times 2, which is 600 cc. So you got this 1-mark question here. Second step is the volume of unused CO2. So volume of unused CO2, you should calculate first how much oxygen is used. So for that, again we'll take the ratio here. C2H6 is to oxygen ka ratio, that is 2 volume to 7 volume. Now C2H6 is given 300 cc, which is, so we will take it as an x, calculate this. The x you will get 7 into 300 by 2. So you are going to get this one, calculate it. This will be 3.5. You will get 1050 cc. So that means oxygen used up is 1050. But in the question you see the amount of oxygen is given 1250. So that means how much this x is the used oxygen and the volume of oxygen unused will be the total amount, which is 1250 subtracted 1050. You will get the answer 200 cc. So both the parts you got the answer, and this is the way you're going to calculate. You can practice similar type of question, and I will be posting more question in the drive, so you can practice more past paper question types. In this type, these are the types of the question possible, where sometimes they are asking the resulting mixture or sometimes they are the specific reagent. But all these types, if they have given both the reactant volume, we need to find it out which is excess and which is used. That is the most important step, because all the answers of subpart depend upon that reagent. So I hope you understood. Thank you for watching. Kindly share, like and subscribe, and I hope you like my videos. Thank you very much.